All right, so this is a key to section 8.1, part 1. And in this case, you're solving systems of equations, in particular, linear systems of equations. And so in this part, though, you want to solve each system by substitution. All right, and so again, you want to write these solutions in order here. Okay, so basically, if you look at the two equations in the system, when solving a system by substitution, you want to choose one of the equations and you want to get one of the variables by itself. All right, so and remember, do it to where it's efficient. So for example, if you choose the first equation, solving for x is going to give you some fractions. So you'll have 2/3 and 1/3 in this equation. We divide everything by 3. The same thing with 2. If you divide all parts by 2, that's 3/2. 2 over 2 is 1, and then 1/2. You don't want to deal with fractions if you don't have to. So if you look at the second equation, though, that's the one you want to use because that equation is already solved for x. So if one of the equations already has a variable by itself, that's the one that you're going to use, and it's probably easier to use substitution to begin with. So in step 1, you're going to take, this would be your step 1. So you say step 1, use the second equation. So let's say take the second equation, x equal 5y plus 6. That's what we're going to use. So remember, step 1 is to pick an equation and solve for the variable. So there's really nothing to do in step 1 because the variable is already by itself. Now when we get over here, there really is going to be something to do for step 1 because you don't see any variables by itself. So then step 2, though, once you complete step 1, then step 2 says this. Substitute this expression here, remember this is what x equals, so x equals this right here. Substitute that into the other equation. So the other equation being the first equation, the top equation. And you're going to substitute that into x because that's what we're saying x equals. Okay, so step 2 says this. So I'm going to take this first equation, and where we see the variable x, I'm going to plug in this expression, 5y plus 6. So I get 3 times 5y plus 6, and notice you put that in parentheses because both terms of this binomial, the 5y and the 6, have to be multiplied by 3. So 5 times 5y plus 6 plus 2y, and that's going to equal 1. So 3x, x is 5y plus 6, and then plus this 2y equals 1. And notice you have an equation here with just one variable, the variable y. And so step 3, remember, is to go ahead and solve this equation for y. So we're going to distribute first. So I get 15y plus 3 times 6 is 18 plus 2y equal 1. Combining like terms, I get 15y and 2y is 17y plus 18 equals 1. Subtract 18 from both sides. Combine like terms, I get 17y equals a negative 17. 1 and negative 18 is a negative 17. Dividing both sides by 17 and reducing. 1 times y is y. So I get y equals a negative 1. So what I found is the y coordinate of my solution, so make sure you put it in the right place. Don't put it here because you're saying that's what y equals, so make sure it's in the second coordinate. Okay, now I got to solve for x. So I got to find out what x is. So step 3, step 4. So step 4, they use the word back substitute. So you're going to back substitute y equal negative 1 into one of the equations. All right. So it doesn't matter which one. Now, normally we go back to one of the originals. So you'll notice that many students, assuming you did step 1 correct, many students will go back to step 1 because that's where the variable is always going to be by itself. So I'm going to go ahead and use the second equation here. So we're going to have x equal 5 times y. Y is negative 1. So where we see the variable y, you're going to plug in negative 1 because that's what we're saying that is. Plus 6. And then 5 times negative 1 is a negative 5 plus 6. and the negative 5 plus 6 is 1. So you found x, so x is 1. All right. Now you can always check. You don't have to, but you can. So what you do is you go back to both of these equations, the original equations, and where we see the variable x, you plug in 1, and where we see the variable y, you plug in negative 1, and hopefully the left side equals the right side for both of those equations. It has to be true for both of them. So if you check the first one and see if it works, so I get 3 times x, x is 1, plus 2 times y, y is negative 1, and you want to see if that's going to equal a positive 1. That's what you're interested in. Well, 3 times 1 is 3, plus 2 times negative 1 is a negative 2, and the question is that equal to 1? And the answer is yes. All right, if you go to the other one, remember the other one has to be true too. So I just rewrote the equation. So x is 1. The question is that going to equal 5 times negative 1 plus 6? Well, 5 times negative 1 is a negative 5, and negative 5 plus 6 is equal to 1. All right. Okay, so let's look at number 2 now. Number 2, notice that in both equations, none of the variables are by themselves. So you got to determine, all right, which of these equations should I use in order to get a variable by itself? So the idea is that you would not use the second one, because if I use the second one, and let's say I want to get x by itself, I would have to divide every term by 5, which would introduce fractions. The same thing for if I get y by itself. I would have to divide all parts, all terms by negative 4, again, which would provide fractions. So choosing the second equation would not be the most efficient method to use. So let's go to the first. Well, in the first, you would not solve for x because I would have to divide everything by 3, which would introduce fractions. So if you look at the variable y, that variable y already has a coefficient of 1, so that's the one you want to use. So step 1 will be choose the first equation, and solve for y. Okay, and so I'm going to get 3x plus y equal 5. Subtract 3x from both sides. Combine my terms. I get y equals a negative 3x plus 5. All right, so that's my y. Now step 2 says this. I substitute this expression. Remember, this is what y equals. Y equals this thing. So I substitute that expression into the other equation. So the other equation, meaning that second equation, where we see the variable y, you're going to plug in, you're going to substitute negative 3x plus 5. So what you're going to end up having is this. You're going to say 5x minus 4 times y. Now remember, always put that in parentheses because both these terms are going to be multiplied by negative 4. So that's negative 3x plus 5 in parentheses, and that's going to equal negative 3. So all I did was I just substituted this expression in place of y. So 3x minus 4y, y is this now, equals negative 3. That's what this says right here. Okay, now distributing. Now remember, step 3 is to solve. That will be your step 3, solve. So I get 5x minus a negative 4 times a negative 3x is a positive 12x. A negative 4 times a positive 5 is a negative 20, and that's going to equal negative 3. Combine like terms, 5x plus 12x is 17x, minus 20 equals negative 3. Adding 20 to both sides, combine like terms, I get 17x is equal to positive 17. Divide both sides by 17. Reducing, 1 times x is x, and 17 divided by 17 is 1. So what I've done is I found the x-coordinate of my solution. So make sure you put, that's what x is, so make sure you put it the x-coordinate. So that's your x-coordinate. Now, I got to find y. So that'll be your next step. So step 4 is to find y. So you're going to substitute. So we're finding y now. Find y. So we're going to substitute x equal 1. So that's what x equals. X equal 1. So substitute x equal 1. That's a 1. Into one of these equations here. Now, many students, they'll just go ahead and substitute into the equation they got for step 1. Now, that's fine as long as you know for sure that you did not make an error. All right, so you can go here if you want to. So we're going to say into step 1's equation, which is y equals negative 3x plus 5. And so we get y equals negative 3 times x. X is 1 plus 5. So y equals negative 3 times 1 is negative 3 plus 5, which is 2. So I found the y coordinate of my vertex. All right, and again, you can check this if you want to. So you can always check. So go back to the both equation. Make sure that equation is true when I substitute 1 and 2. So if it doesn't work, that means you made an error here. You have to go back and find out where your error is. You got to fix it. So my first equation is this, and I want to see if that is a true statement when I substitute x 1 for x and then 2 for y. So I get 3 times 1 plus 2, and the question is that equal to 5? And the answer is yes, it is. That's true. And I go to the next one. 5x minus 4y equals negative 3. So wherever we see the variable x, I plug in 1. Wherever we see the variable y, I plug in 2. So I get 5 times 1 minus 4 times 2. And again, is that equal to negative 3? Well, let's see. That's 5 minus 8, and that is negative 3. So that's correct. So 1, 2, the point 1, 2 is a solution. Okay, so that takes care of 8.1 part 1. And remember, we solved these by substitution. So notice the steps that are involved in substitution.